All right, here we are, folks, getting ready for the end of the chapter. So just going to go through some quick reviews. Remember, the purpose of doing a confidence interval is to estimate either mu or p. So if I'm doing mu, then we're talking about estimating the mean. If I'm talking about p, we're talking about estimating the population proportion. We can also say we're estimating pi, capital Pi, for a proportion. That's the whole purpose of doing a confidence interval. So to do that, for mu, I'm going to go x bar, statistic. Now remember, look at your formula sheet. It's statistic plus or minus critical value times standard deviation of the statistic. And if you look at the table, there's actually a table on that formula card that shows that the standard deviation of a statistic is sigma over root n when you're estimating mu. So for a proportion, we're going to have p hat plus or minus z times pq over n, square root of that whole thing, and bracket for my whole thing. All right, so again, this is only if I know sigma. Now remember, for a proportion, we're always going to know sigma, so it's always going to be z, but for an x bar, we might not, in which case it's x bar plus or minus t times s over root n. All right, make sure that if you're using t that we're using s, and if we're using z, we're using sigma. All right, so just a quick reminder of just some certain terminology. All right, this and this and this is all called the margin of error. Okay, that's our ME for all three of those. All right, so sometimes the question will ask you to find the margin of error, or, what if I want my margin of error to be no more than, in terms of, let's say, percentages, so let's say we're doing it for estimating P, it's a P scenario, margin of error less than 0.03. We want to be within 3% of the actual value. So then I do PQ over N square root times Z less than or equal to 0.03. And if I'm doing 95%, this number here for Z is 1.96. And then I work my way all the way through to find my possible N. Right? The standard error, that is either equal to S over root N if it's T, it's equal to sigma over root N if it's Z, and it's equal to PQ over N square rooted for a proportion scenario. All right? When we're doing problems like this, you're also going to say, all things considered, when all things stay the same, all other things staying the same, what is one thing you can do, one thing to narrow a confidence interval? So if you keep everything else the same, what is one thing that will narrow a confidence interval? All right. So it could be that you increase confidence. If I want to be more confident, increase confidence. If I increase confidence, I'll narrow my interval. If I increase n, increase my sample size, I get a narrower interval. And remember, a narrow interval means more precise. Okay. What are some other things that we can actually do to narrow the confidence interval? There's not much else, because you cannot influence the standard deviation. Changing the confidence interval will change the Z or T, and the N also will increase your confidence level because it decreases standard error because it's in the denominator. And vice versa. If I want to have a wider confidence interval, wider net, I said this the wrong way. This is decrease. If I decrease my confidence, I can have a narrower interval because I don't care as much. If I increase my interval width, increase width of the interval, that means I have an increased confidence because it's the idea of a fishing net. If I want to be more confident, I use a bigger net. Bigger net's going to have more confidence in getting the actual mean or the actual fish. When we're talking about then confidence interval versus confidence level,
it's just real pretty, and where my timeshare is, like at night, there's all these.
Interpreting a confidence level means that for repeated samples of the same size,
No, I'm going to surprise you tonight and take you to
repeated
something that's so
samples
special it'll blow your mind. Okay?
of the same size, I expect, that's expect, trust me, blank percent of them,
Surprise! Everybody's recognized surprise.
them being the intervals,
So anyway, yeah. So
to contain the actual
down
mean.
below my timeshare, all these like Latino, here's Cuban, here's El Salvador, and they all have like different.
That is, if I do a
music.
97% confidence level, that means if I repeat this process over and over and over and over again,
kept
I would
saying,
expect
"Well, I
90%,
come to my timeshare
97% of all the
for
intervals I
years.
create
Go down there and spend a
to
week
contain the
with
actual
my
mean.
wife.
Now that's different than when I do a single confidence interval.
She said,
My single confidence interval is I am blank percent confident that this particular interval contains the actual mean. All right, words I never use is probability that it contains the actual interval or anything along those lines. All right, then the last thing is just make sure you know really, really well all the conditions. All right, think of the flow chart, simple random sample, and then we go down and say, is capital N greater than or equal to 10N? If it is, then they're independent. And then I say, for mu, either if the population is normal, or N is greater than or equal to 30, or the normal probability plot is approximately linear. If one of those three things is true, then, therefore, sampling distribution
So Florida's really a monopoly. So you got to get that little thing for your
is normal.
and then you can zip on the freeway down.
All right. If it's a P scenario, then I have to show that NP and NQ, my expected counts for successes and failures, are both over 10. If I can do that for both, then I can show also that the
It is pretty going up.
sampling distribution is approximately normal. All right, and then lastly is sigma.
Straight on up here.
Ooh, what did I just hit there? Let's go back to this.
Now, the
Sigma.
passageway,
In this scenario, is sigma known?
here and then back,
If the answer is yes, then it's Z. Over here, for a P scenario, sigma is always
go down
known.
there, you go out here, and then you just
All right,
take it
so,
right
so it's
up.
always a Z.
And that's
And then over here, if sigma is not known,
what I do is I
no,
fly on
therefore
and then I drive down
T
to
distribution.
drive back and forth.
All right, that's just a quick little thing. If I get a chance tonight, I will add some more example problems to what we're doing. But standard error, sampling distribution. Sorry, standard error, margin of error. We did all the. Oh, and last thing, robust. We'll just talk about robust for a second, and then I'll let you go. The T distribution is robust. All right,
And then you're about you're
T
3 hours
distribution
from Lauderdale, about.
is
And then
robust.
another hour to
Let's see, if N is more than 15 but less than 30, it can handle some skew,
yeah, I love Florida.
but no outliers.
Like I say, one time was in June, and I don't want to
Some, I would even say moderate skew.
Although, like last
It can handle
summer,
some moderate skew.
and,
If N is less than 15, let's just say it's less than 15, it can handle some skew. I wouldn't say moderate skew, but it can handle some skew. Also, but no outliers. So if there are outliers, and we're talking less than 30, then the T distribution cannot be used if there are potential outliers. All right, if I have N is equal to 45, and I look at it and there is some, let's say I graph it and there's some skew and 2 outliers, I can still use the sampling distribution as normal because this is greater than 3 and the central limit theorem is more powerful than this whole idea of robustness of a T distribution. So there might be a couple outliers when I have a larger sample, and that's more likely to be true. The more you sample, the more data you're going to come in contact with, and the higher likely is that you'll actually see a potential outlier showing up as you collect more and more data. All right. So that's the concept of robust. I know that's a lot. It's really quick. Not an actual problem that I did. But we've done some problems in class, and hopefully you're ready for that. If you need questions, always stop in and see me before school or before the test, and we'll see you then.
I think George is done with